All right, so let's get going on today's class. So first thing we're going to do today is just catch up a little bit on the social media professional development bonus points opportunity. We're actually one assignment behind the other two classes that I'm implementing this in. So to catch up, we're just going to open them up both today. So we'll do number 6 and introduce number 7 for today's class. So social media professional development assignment number 6. This is to continue to help you to develop your brand. And what we're going to do now is we've already been sharing articles and connecting to people in our preferred area of psychology. So what we want to do now is we want to demonstrate that you are current in that particular area, that you have knowledge of and access to the latest developments in any particular area. So to do that, to show that to your network, what we're going to start doing is we're going to start tweeting about 2 recent articles in any area of psychology that you are interested in. And what we mean by recent is that they came out this month. So, for example, I am currently interested in the process of change and how people change and what makes people change in the effort of going through changes myself. So this would be one example of an article in an area of psychology that I'm interested in, 10 things that spark people to make a major change. And as you can see, that is within the month of November. That was November 16th. And then if I was doing this assignment, another one that I might tweet out is this analysis of students' perceptions of their professors and how students perceive professors in different disciplines in different ways. So philosophers are described as brilliant, psychology instructors are more likely to be described as funny, female professors are more likely to be described one way, male professors another way. And again, this is a recent one that's in the area of educational psychology, which is another thing I'm interested in. So that would be 2 examples of the kind of articles that we are looking for. So if you're having trouble finding these, one of the best ways to find these recent articles is to go to Google or any other search engine. Search for the area of psychology that you're interested in. So if it's developmental psychology, just search developmental psychology. If it's psychology of art, just search psychology of art. And then click on the tab that searches for news. So you know how they have the tab for all images in news, shopping as well. Click on the one for news, and that'll bring up the recent news articles. And that would be a way of finding these particular articles about these new developments in your area of psychology. So for this assignment, we're going to use the hashtag IUSB share site. That'll be the way that I can track your involvement in this one. And the due date for tweeting out these 2 recent articles is going to be this Monday, December 2nd, getting into December, by midnight. All right, so that was number 6. We are also going to introduce number 7 as well. So let's do that. All right, so we're also going to introduce assignment number 7 as well. So for assignment number 7, this is going to be developing that connection to your community and actually finding your community in the psychology domain as well. And the way we're going to do this, you've already connected to professional psychologists previously. Now what we're going to do is we're going to connect to professional psychology organizations. So there are a number of organizations out there that are dedicated to the pursuit of psychology and that can help you, especially at the beginning of your career, find your way in the psychology world. So what I want you to do for number 7 is I want you to follow these following accounts. So the first one is going to be Psychi. It's going to be Psychi. There we go. So the first one is going to be Psychi. Psychi is an international honor society in psychology. We have a chapter here at IUSB, and this is a undergraduate and graduate honor psychology organization that if you're a part of, and it will give you details on how to be a part of it, can give you a lot of opportunities in terms of internships, grants, scholarships, and the like. So this will be the first one that I want you to follow to get connected to that world of professional organization dedicated to students in psychology. So that's number one, and you can find the Twitter handle for them right here. So that's @PsychiHonor to follow them on Twitter. Number two is the Association for Psychological Science. This is the probably the second biggest professional organization for psychologists. And again, this can plug you into a lot of opportunities, give you announcements on a lot of events that are occurring, scholarships, job opportunities, PhD and graduate school opportunities. So for this one, that is @PsychScience. So again, just follow that one to get plugged into that network as well. And you can see that it's got 66,000 followers. And then the last one is a little bit more open-ended. And this one has to do with the APA, so the American Psychological Association. And this is by far the biggest professional psychology organization. And it is so big and covers so much of psychology that it's actually divided itself into different divisions. So the link for this, let me just bring it right up there. So there's the link where you can find all of the APA divisions. And here's a partial list of the first 15 of these divisions. So you can see there's a Society for General Psychology, Society for Teaching of Psychology, Quantitative and Qualitative Methods. The one that I follow the most, Society for the Psychology of Aesthetics, Creativity, and the Arts. So what I want you to do for this final follow of a professional organization is find a division that you are most interested in. So for example, for me, it would be the Society for the Psychology of Aesthetics, Creativity, and the Arts. And find this division. On their page, they should have information about their Twitter account if they have one. So that will lead you to their Twitter account, and that's the last one that I want you to follow. Find a division that you're interested in and follow the Twitter account for that particular division. And this one, for example, if you're interested in the psychology of arts, this would be a great one to follow, because literally their top pinned tweet was this one about whether you're a student that's interested in applying to grad school in the psychology of aesthetics, creativity, and the art. Here's a list, a growing list of grad programs. So many times students, when I'm advising them, will ask me, you know what, I want to go to grad school and I want to do it in this area of psychology. How can I find grad programs? Where can I find graduate programs for that? And these divisions are a great way of doing exactly that. So if you wanted to find programs in, for example, art therapy, following Division 10, which is about the psychology of arts, following, I don't know the division offhand, but the clinical psychology division would be two great resources to get that sort of information. So they will post things about conferences, scholarship opportunities, grant opportunities, and just a lot of the latest and greatest work that researchers are doing. So it's a great way to get plugged into those communities by going through these professional organizations. All right, so when you're done, because there's no hashtag for this, we're just following these organizations. If you can upload a screenshot of your of the three follows, just upload a screenshot to Canvas assignments, social media development, step number 7, and that upload will also be due this Monday, December 2nd by midnight. All right, so any questions on assignment 6 and 7? All right. Okay, so what we're going to do now is we are going to introduce and finally cover the idea of confidence intervals. And this is going to be a revisit of chapters 8 and 9, because we're going to see that 90% of calculating the confidence interval is exactly what we did in chapters 8 and 9 when we were calculating t-tests. It's just taking the output one step further to find these confidence levels. So before we begin with those, how to calculate confidence levels, we're going to spend the first part of this class taking a look at what exactly is a confidence level. So I'll give you a few examples. Let's say that you worked for a monkey sanctuary, and it was dedicated to preserving and helping out a variety of monkey species. And one day in this sanctuary, there was a virus. A virus spread amongst all of the adult monkeys. And because of that, they needed to quarantine the adult monkeys separately from the baby monkeys. So rather than having a mother to cling to, all the baby monkeys were left alone. So let's say that this sanctuary knew or discovered about Harlow's monkey experiments. And they knew that they could substitute surrogate mothers for these baby monkeys to give them a little bit of comfort, to give them a little bit of support. They were going to go out and buy terry cloth mothers. Now, this is a real-world situation. And in real-world situations, you have to deal with real-world issues. And one of the real-world issues that comes up in a situation like this is budget. So this monkey sanctuary is not working on an unlimited budget. They probably spent a ton of money on medicine and other medical supplies for the infected monkeys. They're not going to have unlimited money left over to buy terry cloth mothers for every single monkey. So in this case, they would want to know how long do the monkeys spend with the terry cloth mother. They need an estimate of how long do these monkeys spend with the terry cloth mother. And this is very different than what we have done so far, because Harlow, as a psychologist, he was only interested in which type of mother do the monkeys spend longer with, right? So he only wanted to know, do they spend longer with the terry cloth mother or longer with the wire mesh mother? And the t-test that we ran told us that monkeys spend more time with the terry cloth mother. But this sanctuary doesn't need to know that the monkeys spend more time with the terry cloth mother. They need to know how much time do they spend with the terry cloth mother. Do they spend only 12 hours with the terry cloth mother? In which case they only have to buy one terry cloth mother for every 2 monkeys, and the 2 monkeys can share it in a day and each get 12 hours. Do they spend 18 hours with the terry cloth mother? In which case they need to buy more terry cloth monkeys. Do they only spend 6 hours with the terry cloth mother? In which case they need to buy less terry cloth monkeys. They want to make sure that they get enough terry cloth mothers without going over budget. So they want to know not that they do spend longer with the terry cloth mother. They need to know how long do they spend with that terry cloth mother. How many hours? And as we're going to see, that is what the confidence intervals are going to allow us to do. I'll give you another example. We talked about Loftus and Palmer, and we talked about how, depending upon how you phrase a question, it can increase or decrease your estimates of the speed. It can decrease the estimates that you remember about how fast 2 cars were going. So that's very interesting in terms of how our memory works. But let's say that we have a real-world situation where there was a car crash and the person is on trial for vehicular homicide. So the person's on trial, and one of the key ingredients in this trial is how fast was this car going? How fast was the car traveling? Because if it was speeding, that's evidence for a crime. If it wasn't speeding, that's evidence for circumstances, I guess, occurring. So let's say that the prosecuting attorney, the one that's looking for a conviction of vehicular manslaughter, let's say that he asks one of the witnesses, how fast was the car traveling when it violently and egregiously smashed into the truck, right? He has now tainted this eyewitness's memory. however this eyewitness, whatever number this eyewitness comes with, we know from Loftus and Palmer's study that that number is exaggerated, that that number is overestimated. So if you were called as an expert witness, if you were called as an expert psychology witness, they might ask you, how much faster was this eyewitness's memory because of how the question was asked? And in this case, again, as a psychologist, we know from our t-test that it was faster. We know from our t-test when subjects were asked how fast were the cars going when they smashed into each other, that the number that they gave was higher. It was a faster estimate than how fast were they going when they smashed into each other. But in a court case, they might need to know how much faster. Is it overestimated by 6 miles an hour? Is it overestimated by 10 miles an hour? Is it overestimated by 15 miles an hour? Because it might be that if the eyewitness's testimony was overestimated by 5 miles an hour, then that doesn't put it into vehicular homicide territory. But if it was overestimated by 10 miles an hour, that puts it into vehicular homicide territory. So they need to know not that the eyewitness's testimony gave a higher estimate of speed. They need to know by how much, how many miles per hour. And for that, we need to go beyond the t-test. We need to go into confidence intervals. So one last example before we get down to some of the nitty-gritty. Let's say that you, after you graduate from IUSB, you become an industrial organizational psychologist. You do work on the psychology of the workplace and how a workplace operates. And let's say that the very big corporation of America calls you up one day and they have been reading and doing some research. Their R&D department has been doing some research, and they stumbled across that study that we did, we looked at on timeout. So they came across that study that shows that adults are more accurate in a 10-second timeout condition than in a 5-second timeout condition. So they read about that and they're very interested. But in a business, if you are putting your workers in timeout for 10 seconds, you're turning off their screens, you're not allowing them to earn any more money, any more commission. If you put them on timeout for 10 seconds, that's 10 seconds that they're not working. That's 10 seconds that they're less productive. If you only put it in timeout for 5 seconds, that's only 5 seconds that they're not working. So what they need to know is they need to know how much more accurate are they going to be in that 10-second condition. Are they going to be accurate enough to offset the costs of changing and adopting this 10-second system? Are they going to be accurate enough to make up for those lost 5 seconds, those extra lost 5 seconds? They want to know not that they are going to be more accurate in the 10-second condition. They need to know how much more accurate. Is it 5% more accurate, 10% more accurate? How much more accuracy can we expect? And again, for a psychologist, we as theoretical psychologists would just be interested in the fact that they are more accurate in the 10-second condition. That proves that timeout is effective for adults. But for a business, for a corporation in the real world, dealing with some real world problems, it's not enough that they're more accurate. They need to know how much more accurate so they can make that decision on whether or not it makes financial sense to implement that 10-second timeout condition. All right, so that is what we're going to be looking at today. So we're going to first introduce the idea of confidence intervals, what a confidence interval is, what estimation is at its heart, and then we're going to take a look at how to do one of the 3 confidence intervals that we're going to be working on. So we're going to take a look at a single sample t-statistic, how to calculate a confidence interval from that situation, and that will be hopefully where we end up at the end of today. All right, so an overview of confidence intervals. What are we trying to do? Well, confidence intervals are for estimation. So estimation is where you use inferential statistics, like our hypothesis test, and you want to use a sample statistic. You want to calculate something based on the sample that you can measure, and then say something about the population in general. So we're using our sample to estimate something about the population. And in order to understand confidence intervals, you have to understand that they're made up of two parts. They are made up of a point estimate, and they're also made up of an interval estimate. So you have a point estimate, that's the center of your confidence interval, and then you have an interval estimate, that is the width or the range of your confidence interval. And this is a way of sort of combining the best of two worlds, because in estimates in general, these two point estimates and interval estimates are often contrasted because they have basically exactly the opposite of each other. So a point estimate, this is a single number that is used to estimate an unknown quantity. It is one number, it's your best guess, but it is a single score, a single raw score. So let's say that there was a bank robbery. You witnessed a bank robbery, and afterwards the police are interviewing you, and they want to know some of the physical characteristics of the bank robber. So they might ask you a question: how tall was the bank robber? How tall was the woman that held up the bank? And you might take a look at the police officer and you might say, you know what? I think she was 5'6". That is a point estimate. So you are giving a single number, 5 foot 6 inches tall, and that is an estimate of an unknown quantity. We don't know what she actually is. We don't know what her height actually is, but that's our best guess. That's our best estimate. That's a point estimate, single number. On the other hand, an interval estimate is a range of values that you can use to estimate a quantity. So in this case, if the police officer says, well, how tall was the bank robber? Instead of just giving one number, you might give a range. You might say, well, she was between 5'2" and 5'10". She was somewhere within that range. So that's an interval estimate, range of numbers, point estimate, single number. I mentioned before that they have pros and cons and that they are the opposite of each other. So what are those? Well, the point estimate has very, very high precision. It lets you know exactly what the estimate is. It's exactly 5'6". So it is very precise, it's very exact, it's got high precision. On the other hand, your interval estimate has very low precision, right? So it could be anywhere between 5'2" to 5'10". You're not being very precise. It's hard to plan, for example, for the future, if you know somebody's between 5'2" and 5'10". So it's hard to buy pants for somebody that's between 5'2" and 5'10". If somebody's 5'6", you kind of know exactly where you stand. So it's got low precision, not very precise for the interval estimate, high precision for the point estimate. That precision, though, comes at a cost because a point estimate has very low confidence. You cannot be confident in your point estimate. And the reason for this is because of the high precision. So you estimated that this person was 5'6". You have a very low chance of being right. In fact, you can only be correct if this person is 5'6". So if the police officer says, do you have confidence that the perpetrator was actually 5'6", you would have to say, no, I have no confidence that they were. Because maybe they were 5'4". Maybe they were 5'8". Maybe they were 5'7". Maybe you're only an inch off. You're still wrong. Maybe they were 5'6½". Maybe you're only half an inch off. You're still incorrect. Because you have a highly precise estimate, 5'6", that gives you low confidence. On the other hand, the interval estimate has very high confidence. So if the police officer asks you, are you sure? Are you confident she was between 5'2" and 5'10", you can say, yes. Yes, I am confident. Because if she was 5'6", you're correct. If she was 5'5", you're correct. If she was 5'8", you're correct. If she was 5'9", you're still correct. There's an entire range where your estimate is correct, so you can have more confidence that you've estimated it correctly. So you're not being very precise, but you are more likely to have that correct. And the interesting thing about the interval estimates is that high confidence, jumped it a bit, that high confidence increases the bigger your estimate is, the bigger your interval is. So if the police officer says, all right, 5'2" to 5'10", are you sure? You might say, yes. Yes, I am sure. And they might say, are you really sure? And you might say, yes, I'm really sure. I'm very confident. And if they ask you, are you really, really sure? You might say, well, no, I'm not really, really sure. And they might say, well, we need you to be really, really sure. And you would say, okay, well, in that case, she's somewhere between 4'8" and 6'2". I am really, really sure that she's between 4'8" and 6'2". So in order to get more confidence, you make that interval bigger. And if the police officer comes back and says, are you really, really, really sure? 4'8" and 6'2", are you really, really, really sure? You might say, no, I'm not really, really, really sure. She's somewhere between, if you want me to be really, really, really sure, she's somewhere between 4'6" and 6'6". And if the police officer comes back and says, look, we absolutely need you to be super positively, really, really, massively, mega sure, what is your estimate? You might say, all right, if you need me to be super, absolutely, positively, really, really, mega sure, if you need me to be that confident, I can do that for you. The perpetrator was somewhere between 6 inches tall and 12.5 feet tall. And you can be very confident that somewhere within that range is the correct estimate of that person's height. So that's an illustration of how confidence can change with the size of the range. Bigger ranges equals bigger confidence. But as statisticians, we don't like to talk about really sure versus really, really sure versus really, really, really sure. We like to put numbers on that. And that's what we're going to be doing today. So we're going to see how you can create these intervals that will give you a specified level of confidence. So you can be 80% sure, or you can pick an interval that'll give you, that'll allow you to be 95% sure, or you can pick an interval that'll allow you to be 99% sure. You can pick an interval that gives you whatever specified level of confidence you need, and that is the confidence interval. All right, so any questions so far on point and interval estimates? Okay. So where is this coming from? How do we do this? How do we come up with this interval? So typically, as I said, this builds on the end of hypothesis testing. And usually, the confidence intervals are only done when you find out that there's an effect. So you find out that there's a difference, you find out that there's an effect, and now you want to find out how big is the effect, how big is the difference. So that oftentimes is a starting point, because we know for our sample mean, once it reaches the tail here, we know from our hypothesis test that our mean no longer belongs to the original population, it now belongs to a new population. And we might ask ourselves, well, what is that new population? So we use our sample to estimate the mean of our new population. We use our sample to say, these guys no longer belong to the old population. What's this new population like? So remember that we never compare samples to populations. We always compare samples to the distribution of sample means. And this is where we're going to find our ability to do this confidence interval. Because our sample, through the hypothesis test, we have discovered our sample belongs to this treated population. It came from this treated population. But we do not know whether our sample came from the center of the population, so whether it came from the distribution of sample means that are right at the mean of the population. We don't know if it came from a more extreme section of the population. We don't know if it came from a really extreme section of the population. We know that it came from the treated population, but we don't know where. So when we're trying to estimate what is the mean of this treated population, we have no idea where our mean actually came from. And that's where we need to have a confidence interval. So we can be a certain amount of confidence, or have a certain amount of confidence, that our estimate actually contains the population mean. So let's stretch this out. We'll center it and we'll stretch it out just so that we can illustrate this a little bit better. So this is your distribution of sample means. from your treated population. That mean right there is what you're hoping to estimate, right? We have this population, we've treated it, it's shown an effect. We now want to know what is the new mean of this population? What is the effect? What is the size of the effect? That is the mean right there in our distribution of sample means, because that is the same as the treated population. That is exactly what we're trying to estimate. So in this case, we'll draw a line right down the center, and if we have an interval or a point estimate that falls on this line, it means that we have estimated our population mean correctly. All right, so that's the visual we're going to work with. If our estimate is on this line, that means that we have estimated our population mean correctly. And that's what we're trying to do. So let's take a look at the first example where our point estimate, our sample mean, actually falls right on our population mean by chance. All right, in this case, we have correctly estimated the population mean, right? Our sample mean, we calculated it, we have those numbers, we calculate the sample mean, and just by chance it lands on the population mean. Remember, importantly, we don't know what this population mean is, so we don't know if this is the situation we're in. But let's just say that we are for present purposes. And let's see what's going to happen if we have a mean that's at the center, a sample mean that's at the center of this distribution. What happens when we make a range that is as wide as the body of this distribution? So you'll notice that we have a little bit of room in the tails here. We got most of the room in the body here. Let's say that we have 90% in the body, and we have a total of 10% in the tails. 5% on that side and 5% on that side. Let's go with that setup for right now. So we got 90% in the body, and we got 10% total in the tails. So we got 90% in the body, and in the tails, we got 10% total, so 5% on each side. Okay, so if we end up with a mean that is right in the middle, we've correctly estimated it, and then if we put a range around it that is as wide as the body of this distribution, then we have also correctly estimated it. Our mean is inside of our range, population mean is inside of the range. That means that we have estimated it correctly. However, we're not always going to get that lucky with our sample. We're not always going to have a sample that is right at the center of that population mean. What happens if that is our sample? That's our sample mean. So we are overestimating the population mean. We have not estimated it correctly. Our point estimate has missed. But notice when we make a range that is as wide as the body around this center point estimate, notice that the range still contains the population mean. So the range that we have here is still a correct estimate. It's still a successful estimate of the population mean because it contains that population mean. All right, so is that understandable so far? That the estimate contains the mean, so it's a successful estimate? All right. So, for this sample here, the sample mean itself misses the population mean, but the range contains the population mean, successful estimation. For this sample here, the point estimate, the center, misses the population mean. But notice that the range, once again, contains the population mean. The range is a successful estimate. And we have that for this sample over here. The range contains the population mean. It's a successful estimate. And it happens for this sample over here. And it happens for this sample over here. And it happens for this sample over here. And for this sample, and for this sample, and for this sample, and for this sample. So notice, and for this sample. So notice it has happened for every single one of these samples. The range of every single one of these intervals, with the center of it being the sample mean, the range of all of these contain the population mean, all of these situations would lead to a successful estimate of the population mean in this case. However, that's not always the case. In this case, we have a sample that has this mean over here, and it misses the population mean. It missed that population mean. It's outside of the interval. So this interval is an unsuccessful estimate of what this population mean actually is. This is the first time we failed. This is the first time we were unsuccessful in our estimation. But notice also that this is the first time that this mean came from the tail. So it is only when a mean ends up in the tail of our distribution that we're going to miss estimating the population mean. And given these numbers here, what's the probability that our sample is going to come from one of the tails? If we have 90% of the distribution in the body, and we got a total of 10% in the tails, what's the probability that we would just randomly end up with a sample that came from the tails? 10%. So we have, if we make a distribution that is, an interval that's as wide as the body, the only time that that interval is going to miss properly estimating the population mean is if we end up with a sample that came from the tail. And again, we don't know which sample we have. We don't know what we drew from the population. But the only time we're going to miss is if our sample comes from the tail. And we know that we have a 10% chance in this situation, a 10% chance of our sample coming from the tail. So if it only misses when our sample comes from the tail, and there's a 10% chance that our sample comes from the tail, that means we have a 10% chance that our interval is going to miss the population mean. If we have a 10% chance of missing the mean, we have a 90% chance of hitting the mean. We have a 90% chance of our interval covering the mean. Therefore, we can be 90% confident that we have correctly estimated the mean. Therefore, we have a 90% confidence interval. So the interval, if you make it whatever body you choose, the size of the body is going to be your confidence that you're going to estimate correctly. The size of your tails are going to be the confidence that you're going to miss that estimate. So this 90% of the distribution that we place in the body, that determines the width of your interval. And if you are 90% sure that a sample that comes from the body is going to be correctly estimating the population, then you only have a 10% chance that it's going to come from the tails and incorrectly estimate the population. Therefore, you can be 90% sure that you're confident that your interval will correctly estimate the population. You have a 90% confidence interval. All right, are there any questions about that kind of conceptual idea? Okay, so just to kind of give you a look behind the curtains before we turn to SPSS to actually calculate this, the basis of your confidence intervals, the portions of your confidence intervals, that comes directly from the equation for the t-statistic. So if you recall, the equation for the t-statistic is your sample mean minus your population mean, all of that divided by your estimated standard error. Well, notice that when we are trying to estimate the population mean, there it is right there. So if we want to try to estimate that unknown population mean, as long as we have a t-statistic and a sample mean and an estimated standard error, we can estimate that population mean. We just need to isolate for it. So we do a little bit of arithmetic, a little cross multiplication. We bring the population mean over, we change its sign. We bring the minus t times the estimated standard error over, we change its sign. We realize that a t-statistic is both positive and minus. And we end up with the equation for a confidence interval. That is, your estimate of the population mean is going to equal your sample mean plus or minus your t-statistic times the estimated standard error. And your t-statistic is what determines how wide your body is. All right, your t-statistic is what determines how big your tails are, because that's your line in the sand. So just to kind of give you a visual of this, we'll isolate one confidence interval. So the population mean, that's what we're trying to estimate. That is that right there. That population mean equals your sample mean. That is that right there. Plus or minus t times the estimated standard error. That is your length of one side of your interval. So that plus is the length of the positive side. The minus is the length of the negative side. So to put it into statistical terms, your population mean mu, that equals your sample mean m, plus or minus your t-statistic times your estimated standard error. And this is, again, a point estimate, which is your sample mean. That's the center of your distribution, your confidence interval, plus or minus a range, that is the t-statistic multiplied by the estimated standard error. That is your point estimate plus your interval estimate. Take those together, you have a confidence interval. All right, so let's take a look at, we'll put some numbers on this just real quick, and then we'll do an SPSS calculation. So let's say that our sample mean, we're trying to estimate an unknown population, and our sample mean, the unknown population, and our sample mean is a mean of 100 plus or minus, and the t times the estimated standard error happens to be 11.5. If our population mean is actually 100, that means that plus 11.5 will be this tail right here, minus 11.5 will be the beginning of this tail right here. So we've got 88.5 over here, 111.5 over here. And if we end up with a sample, so this is our population mean of 100. If we end up with a sample of 100, so we do our experiment, we test our sample, and the sample mean just happens to be 100 after the treatment, well, we have estimated our population mean correctly, right? We don't know what that population mean is, but if this is the situation, we got lucky, we estimated it correctly. That's going to happen very rarely. That's a point estimate. We put an interval around it that is as wide as this body over here. It goes all the way up to 111. That's where this tail begins. And all the way down to 88.5. That's where that tail begins. And that's how wide our interval is. Whenever we get a sample that comes from the body, that interval will cover our population mean right here. So from 105, our point estimate misses it, but notice this interval goes from 93.5 to 116.5. Notice 100 is right there, correct estimation. If our sample mean was 95, we missed it. However, the interval around it that we have determined, notice that it covers 100. 100 is right there. So 100, the correct population mean is in our interval, correct estimation. 110, we missed it, right? Our sample mean misses the population mean, but our interval covers it because it goes all the way up to 121.5, but all the way down to 98.5. There's 100 right there, successful estimation. And again, this happens any time that our sample ends up coming from the body of our distribution. And the only time it misses is if we are unlucky enough to get a sample that is already in the tail. So in this case, we got a sample of 115. That misses the population mean. And the range as well misses the population mean. But again, this only happens when your sample comes from the tail. So it only happens in this case when the sample will come from the tail, and if that tail is 5%, the two tails together are 10%, so we only have a 10% chance of missing the estimation. We have a 90% chance of hitting it. We have a 90% confidence interval. And again, it works on the other side as well. If we go too low, our interval misses, and again, that only comes from the low side of the tail. All right, so that is what I wanted to cover kind of conceptually. And what we're going to do to round out the sort of meeting portion of today is we are going to do an in-class kind of demonstration of how to do a confidence interval test. And before we get to that, just a sort of forewarning. Sometimes students get a little, well, I'm not going to interpret their emotions for them. But what you're going to find is you're going to have a little bit of a Dorothy moment right here. You're going to have a little bit of a moment of Dorothy from The Wizard of Oz. So you are going to find out that this entire time you have actually been calculating confidence intervals. So we are going to go through how to calculate confidence intervals today. But what you're going to find is that you have actually been calculating these all along. So hopefully you'll see the point of saving confidence intervals until today, but that's just my little forewarning for those confidence intervals. All right, so the example we're going to go through, monkey sanctuary, Harlow's study. So once again, we've already analyzed Harlow's monkey study. We already know monkeys spend longer with the terry cloth mother. But a monkey sanctuary that needs to buy terry cloth mothers for its quarantined infants doesn't need to know that they spend more time with the terry cloth mother. They need to know how much time, how many hours. So that's a confidence interval question, and that's what we're going to turn to today. So the first thing you need to do when you're calculating a confidence interval is you have to read a description of the experiment that the data came from, and you have to decide what sort of test is it that you need to do. Is it a single sample t-test? Is it an independent means t-test? Or is it a dependent means t-test? In this case, we've already seen this example a few times. We already know that how to set this up. We already know that this is a single sample t-test. So that's the first step. Read the description, decide, is it a single sample t-test, dependent means t-test, or independent means t-test? The next thing to do is to see what question the people need to know. And there's two types of questions they can ask. They can ask how much of something is there, or they can ask how much more of something is there. They can ask, the first one is, what's the amount of something? The second question is, what is the difference of something? So those two things can both be asked. All right, and we're going to introduce it first with the how much of something question. So in this situation, the monkey sanctuary would want to know how many hours per day do the monkeys spend with the terry cloth mother. Not how many more hours a day do they spend with the terry cloth mother. They want to know how many hours a day do they spend with the terry cloth mother. And then we are going to compute three different confidence levels. We're going to compute a 95% confidence interval, we're going to compute an 80% confidence interval, and finally a 99% confidence interval. And we're going to be doing all of this in SPSS, so I need to, at this point, fire up my SPSS. If you haven't done so already, this would be a great time to do that, and let's get that going. Okay, so while SPSS is loading, I'll just show you the Excel sheet that we're going to be working off of. So once again, in order to do the SPSS confidence intervals, you need to have access to the raw scores. So just like doing an independent, a single sample t-test, we need to have the raw data in order to do the t-test. Yep. So that's this is the scores that we're looking for. They're the same as the ones that we've used before. And the first thing that we do for a confidence interval is we set up the t-test for the data. So we have decided this is a single sample t-test. So we are going to set up a single sample t-test. So we'll copy that. We're going to paste it into SPSS. And then we are going to label that once again so that we don't forget what it was that we were looking for. And then once we have our data set up, we're going to go to Analyze, we're going to go to Compare Means, and we're going to go to one sample t-test. All right, so is everybody at that point, at this point? All right. So once again, we go to that one sample t-test, and we click on it, and we set it up much like a normal t-test. There's only two things, though, that we're going to do a little bit differently. The first thing that we're going to do is we're going to go to options here. So we have ignored this little options tab. We're going to click on options right now. And as you can see, it really doesn't have very many options except for this confidence interval percentage. This is where you enter the amount of confidence that you want to have. So for example, in our question, we said that we want to have a 95% confidence interval. That is definitely the most common one, and you can see that SPSS is already set up to do a 95% confidence interval. So the first thing to do is to click options, make sure that that has the confidence interval that you want, and then we hit continue. The second thing has to do with this test value over here. And I'm going to do this a little bit differently than I've done in the past, and hopefully this will make a little bit more sense. That test value is what you're going to compare your raw scores to. But remember that we're no longer doing a t-test. We're doing confidence intervals. So you have to ask yourself, what is it that they want to know? Do they want to know how much more time they spend with the terry cloth? Or do they want to know how much time do they spend with the terry cloth mother? If they want to know how much more time do the monkeys spend with the terry cloth mother, then we put in the test value like we were doing before for the t-test. We put in the test value, that's the hypothesized mean. We would put in 9 hours, and we would find out how much more than 9 hours are they spending with the terry cloth mother. That would be the confidence interval that SPSS would calculate for us. However, they did not ask us how much more than 9 hours are they spending with the terry cloth mother. They've asked us how much time are they spending with the terry cloth mother. And if that is the type of confidence interval that you're trying to estimate, you're trying to estimate a how much confidence interval, not a how much more confidence interval. If you're looking for a how much confidence interval, we're going to keep the test value at 0. So if we take a look at our question here, they want to know how many hours per day do the monkeys spend with the terry cloth mother. That is, how much time do they spend with the terry cloth mother? That is a how much question for a how much confidence interval. So for that, we're going to keep the test value at 0. So we're going to keep the test value at 0. We have the test variable, the terry cloth. We put the options in for the confidence interval that we want. We hit OK. And you can see the typical t-test output right here. And notice, we never drew attention to it before, but notice at the end of this table here, we have something that says 95% confidence interval of the difference. That is where we're going to get the info for our 95% confidence interval. So before we interpret this, this output, we're going to run the other two confidence intervals. So we can go just right back to the data editor, and we have everything set up the way that we want. So we can go back to analyze, we go back to compare means, we go back to that one sample t-test, and this time we're going to go to options, and we're going to calculate the 80% confidence interval that we were asked for. So this would be a situation where you have one person that works at that monkey sanctuary, and they only feel like they need to be they feel like they want to be 95% confident that they buy enough terry cloth mothers. Somebody else might not be that worried, and they might say, you know what, I don't need to be 95% sure. 80%, good enough for me. That'll help me sleep well at night. So we're going to calculate an 80% interval. So we do that very easily. We just go into options, change the confidence interval percentage to 80, hit continue, hit OK, and you'll notice that SPSS has now calculated an 80% confidence interval of the difference. Very nicely, SPSS will label them. Just in case you calculate multiple confidence intervals, it's very nicely labeled. This is the 95%, This is the 80%, just in case you forget. And we were asked for one last one, so we were asked for a 99% confidence interval, and that would be a person who absolutely, positively needs to make sure that we get enough terry cloth mothers. They won't sleep at night unless they're 99% sure. So once more, we go to analyze, compare means, one sample t-test. Everything is set up. We go to options, and now instead of 80%, we put in 99%. We hit continue, we hit OK, and sure enough, there is our 99% confidence interval of the difference. All right, so now we're going to get to the point where we need to interpret all of this. So is everybody able to calculate those confidence intervals, do those t-tests? All right, so now we're going to interpret this, and what we need to do is we need to take that output, and I'll zoom in a little bit so we can see it, and we need to start interpreting that output. Now, if you are looking for the components of your confidence interval, if you're looking for that mean plus or minus the t-statistic multiplied by the estimated standard error, SPSS will actually give you some of that information. So for example, that estimated standard error that we're using right there, that's that value right there. That's that estimated standard error that we have looked at before. And the t-statistic that you would use if you wanted to do this manually to calculate these cutoff scores here, that t-statistic is nowhere on the table. But SPSS will help you find it because it does give you the degrees of freedom. And you would take those degrees of freedom and you would go to that t-statistic table and you would look it up if you wanted to find all the pieces of this particular confidence interval. For us, it's a little bit easier because we are just going to look at the 95% confidence interval of the difference. Now, what we're going to do is, this was prepared the other way. I called an audible here last minute. So we are going to go back to SPSS. We're going to take a look at that output. And I'm going to run you through what I hope is an easier way of calculating out these confidence intervals. All right, so for a confidence interval, the challenge that we need is that we want to get a confidence interval in the form that most people understand, which is a point estimate plus or minus some range. All right, so we are knee deep in the political elections these days, and I'm sure you've heard polls being taken where people will say things like, oh, so-and-so has 18% support plus or minus 2%. That's a confidence interval. That's a point estimate plus or minus some range. So we want to get it into this format here, but SPSS gives it to us in this format. It gives us our sample mean, it gives us the point estimate plus or minus a certain range. And the places where we find this information are in the following. The first place we find the information, that mean difference, right there, that is your point estimate. If you have set up your hypothesis test correctly, that is, you chose the right test value. 0 if they were asking for how much, hypothesized mean if they were asking for how much more. In this case, they were asking for how much. That mean difference right there tells us how much. So our best estimate, if we could only give them one number, we would look them in the eye and we would say, well, our best estimate, our point estimate, is 15.3 hours. That is how long these monkeys will spend with a terry cloth mother. I don't have a single. We'll go to green. All right, so that's our best estimate. But we need a range. And in this case, we're calculating out that 95% confidence interval. This range here is given to us right here. So this 95% confidence interval of the difference, that tells you the lower end of the range and the higher end of the range. So the end point right here, that is 11.3. All right, that's 11.3 hours. The end point right here, that's 19.3. That's 19.3 hours. So we can be sure, we can be 95% sure that the actual time that these monkeys spend with the terry cloth mother is going to be between 11.3 hours all the way up to 19.3 hours. That's the range. So this is our confidence interval, but we want to put it into this form here. We want to have it in the form of a point estimate plus or minus a certain range. So for that point estimate is the center of your confidence interval. In this case, if you set it up correctly, the point estimate is that mean difference. So our best guess, our single best number is 15.3 hours. That's how long monkeys spend with the terry cloth mother. For the plus or minus, we need to find how big is this interval here. It's a horrible parentheses. We need to find out how big this interval is here. And the way that we do that is we take, this is the, one of the ways, there's multiple ways, but this is the one of the ways, it's the most straightforward way. We take the upper limit and we subtract the center. So if you take the upper limit, 19, in this case 0.29, and you subtract away the center, 15.3, we're going to end up with 3.99. That is the length of this arm. It's also the length of this arm, right? It's symmetrical. So you can always, whether you're dealing with positives or negatives, whether this one is negative and this one is positive because you cross zero, whatever the situation is, you take the upper limit given to you, you take the center, upper limit minus center will always give you that plus or minus, and in this case, it's plus or minus 3.99. And that is your final confidence interval. All right, so that is the calculation of a confidence interval that I wanted to show you. So now to sort of wrap up our look at confidence intervals, I'll just mention a few things here. So when we calculated those out, we calculated the 95% confidence interval. So again, we kind of did it a new way. So what we ended up with is, remember that there we go. No, we don't. All right, so remember that this sample that we had, in that sample, monkeys spent 15.3 hours with the terry cloth mother. That is our best estimate for how long they're going to spend with the terry cloth mother. Thank you. So that's our estimate for how long they're going to spend with the terry cloth mother. That's our best point estimate, right? And that estimate is shown. Oh, tech. That estimate is shown right there. So that's our best guess, 15.3. That's why it's the center of our confidence interval. We just calculated the 95% confidence interval, and we saw that it was centered on 15.3, plus or minus 3.99. That plus or minus 3.99 hours, that gives us 95% confidence that we've estimated how long they spend with the terry cloth mother correctly. For the person that was only 80% confident, if you try this out, you will see that that 80% confidence interval is smaller. Smaller interval means less confidence. It's only plus or minus 2.42. And the person who was super worried about the baby monkeys and needed a 99% confidence interval, notice that to get 99% confidence, you have to go really wide. You got to go 15.3 plus or minus 5.81. So first thing to notice, all the confidence intervals are centered on the same estimate. That is your best guess. That is your best sort of estimate of what you think the hours are going to be. The next thing to notice is that as confidence increases, the range has to increase as well. All right, so that's what I wanted to cover for today, sort of as an intro. So we are not completely done with confidence intervals yet, but I just want to sort of bring to your attention the homework that we have. So there is a homework assignment for confidence intervals. It is an Excel homework assignment. So it is available in Canvas. It's available in the Excel sheets. Sorry, in the homework Excel sheets. And it looks, let me see if I can get that. It looks like, this. Thank you. There we go. All right, so this is your homework assignment. This is the way that it looks. You are ready to go on some of these, so you can get a jump on this homework assignment. It's not going to be done for a couple of weeks. Well, not a couple of weeks. It's not going to be done for a little bit because of the Thanksgiving holiday. Plus, we're not quite done with confidence intervals. But if you wanted to give it a shot, you are ready to go. So there are confidence intervals here for independent means t-tests. There are confidence intervals here for dependent means t-tests. And there are confidence intervals here for single sample t-test as well. So you are ready to go on the single sample t-test. And I also just want to point out that, once again, make sure that your answers go into the yellow answer cells. The point estimate is always going to be the same. So what you're looking for each of these confidence intervals is to calculate a confidence interval and then put it in the format of a point estimate plus or minus a certain range. So this is your point estimate plus or minus, this is your certain range. So it's not going to be due until the week, into the week when we get back, because we still got one more class on confidence intervals. But if you want to give that a go, feel free. And this will be another one of those where you have as many attempts as you want. It will grade your answers automatically. So feel free to try this over and over and over again if you're not getting it right away until you get 100% on that particular homework assignment. And that is our final pre-Thanksgiving statistics class. So that's about all the time that we have for today. So again, you can start up on your homework, if you have a little bit of time during the break. If not, it's not due until the class after we come back. So feel free to take a little bit of time off from stats if you like. I'll be grading your exams and posting that also in the meantime. But that looks like it's about it for today, and that is all that I wanted to cover. So we are good. And if anybody has any real quick questions, let me know. Other than that, enjoy your Thanksgiving break.